According to a severe test, one is justified in declaring to have evidence in support of a hypothesis, just in case the hypothesis in question has passed a severe test, one that it would be very unlikely to have passed so well if the hypothesis were false. Deborah Mayo calls this the strong severity principle, which states that we have evidence for a claim C just to the extent it survives a stringent scrutiny. If C passes a test that was highly capable of finding flaws or discrepancies from C, and yet none or few are found, then the passing result X is evidence for C. In a persuasive defense of statistical inference as severe testing, Deborah Mayo argues that Bayesian inference is unable to guarantee that the strong severity principle will be met. A Bayesian can declare to have evidence for a claim despite not having done anything to severely test that claim. The core reason for this has to do with the infamous likelihood principle, whose violation is usually considered not to be an option by anyone who subscribes to the Bayesian paradigm. Here's a statement of it by Berger and Walpert. All the information about a parameter theta obtainable from an experiment is contained in the likelihood function for theta given X. Two likelihood functions for theta from the same or different experiments contain the same information about theta if they're proportional to one another. But what exactly does it mean to say that all of the information that some data X provides about parameter theta is contained in the likelihood function? To see how the likelihood principle should be interpreted in Bayesian confirmation theory, let me first briefly introduce some key terms. So let S be a set of mutually exclusive, collectively exhaustive hypotheses, and let H be a variable ranging over members of S. Let E be a set of observed data. The likelihood function for H is then the joint probability of the observed data E as a function of H. Now, let measure C indicate the incremental confirmation that E provides for H, where for Bayesian incremental confirmation simply means that the data, if learned, would raise the probability of the hypothesis. We're now ready to state the likelihood principle in terms of Bayesian confirmation theory, which states that if the likelihood functions for H are proportional, then for all H in S, the incremental confirmation that E provides for H will be the same as the incremental confirmation that E star provides for H. Now, one might think that the likelihood principle follows directly from Bayes' theorem. However, this is not the case, since, as we've seen, the likelihood principle is a claim about relative confirmation, while Bayes' theorem is a statement about probabilities. That is, Bayes' theorem says something about the probability of H given E, but nothing about the incremental confirmation that E provides for H. Nonetheless, the Bayesian argument for the likelihood principle does rely on a consequence from Bayes' theorem, together with an additional assumption, which is usually taken for granted by Bayesians. From Bayes' theorem, it follows that if the likelihood functions of H are proportional, then the posterior probability of H conditional on E will be the same as the posterior probability of H conditional on E star for every H. I won't give a proof, but it's easily proved, and everyone. And from this consequence of Bayes' theorem, together with the additional assumption that if the posterior probability of H conditional on E is the same as the posterior probability of H conditional on E star, then the confirmatory value that E provides for H will be the same as the confirmatory value that E star provides for H. Then we get the likelihood principle. Although in the Bayesian literature, there is considerable debate on what should be the correct quantitative measure of incremental confirmation, I think all Bayesians are happy to endorse either implicitly or explicitly this additional assumption, and hence are happy to endorse the likelihood principle. Now, as mentioned earlier, for anyone who believes in the strong severity principle, the likelihood principle must be wrong, since it entails that inferences about a hypothesis depend exclusively on the outcome of an experiment and not on its design. But according to the severe tester, considerations pertaining to the design of an experiment, for instance, whether someone deliberately stops an investigation depending on what the data looks like, are relevant for assessing the severity with which a hypothesis has passed the test, and consequently whether one has evidence in support of a hypothesis. The Bayesian, however, seems to be largely unmoved by the incompatibility between the strong severity principle and the likelihood principle. According to the Bayesian, the likelihood principle must be right, and the strong severity principle, severity principle wrong, if incompatible with it. In this talk, however, I want to discuss a very distinct notion from that of severity. This notion is usually referred to in literature as the weight of evidence, and it is often claimed that John Maynard Keynes was one of the first to raise attention to it. Although, as we will see, this notion has very little, if anything, to do with severity, the reason why I think it's an interesting notion to discuss in relation to the likelihood principle is that I think the Bayesian's never-ending quest for some way to account for the latter betrays the Bayesian's confidence in the likelihood principle after all. That is, I will argue that the Bayesian's recognition that the posterior probability that one assigns to a hypothesis given the available evidence is unable to reflect something that the Bayesian itself seems important about the nature of that evidence, that is, its weight, is merely a symptom of the Bayesian's own dissatisfaction with the likelihood principle. According to the Bayesian, there is more to say about the evidence for a hypothesis than its likelihood function, given that evidence, and yet the Bayesians can't account for what that something is. So the outline of this talk is as follows. So first, I will introduce Keynes' notion of the weight of evidence and what the Bayesian has had to say about it. I would then argue that the Bayesian's never-ending quest for some way to account for Keynes' notion of the weight of evidence betrays the Bayesian's confidence in the likelihood principle after all. And finally, I will try to convince you that the failure to recognize that Keynes' notion of the weight of evidence is not, in fact, an epistemically well-conceived notion is causing a great deal of trouble and confusion to this day. For instance, when it comes to discussions about what it means to provide sufficient supporting evidence for legal claims, and also in various attempts to conceptualize uncertainty to policymakers by institutions such as the IPCC. Okay, so what is this thing called the weight of evidence? Below is an often quoted passage from Keynes on this notion from his treatise on probability. So here's what Keynes said about it. As the relevant evidence at our disposal increases, the magnitude of the probability of the argument may either decrease or increase according as the new knowledge strengthens the unfavorable or the favorable evidence. But something seems to have increased in either case. We have a more substantial basis upon which to rest a conclusion. I express this by saying that an accession of new evidence increases the weight of the argument. New evidence will sometimes decrease the probability of an argument, but it will always increase its weight. Now, it's well known that Keynes was an advocate of logical probabilities. That is, according to him, probability was supposed to be a logical relationship between some premises E and a conclusion H. However, what Keynes is getting at in this quote does not depend on his particular interpretation of probability, so we don't have to worry about that. So as hinted in this passage, according to Keynes, the weight of evidence has to do with the amount of relevant evidence at our disposal. And that is that as the amount of relevant evidence at our disposal increases, the weight of evidence will also increase. From this conception of the weight of evidence, it is clear that the posterior probability of a hypothesis conditional on some evidence E is completely independent from the weight of that evidence. That is, the addition of some relevant evidence to the evidence at our disposal will always increase the weight of the evidence independently of how it affects the posterior probability of a hypothesis. Now, there are in fact reasons to suspect that any hope of directly measuring the weight of evidence or even comparing the weight of two sets of evidence is unwarranted in most cases. Keynes himself seemed to believe that, and others have also argued that there is no broadly applicable metric for the amount of one's evidence with respect to a hypothesis. And without such a metric, weight may not be a linear ordering. That is, it may not be the case that for every two sets of evidence regarding a hypothesis, either one has greater weight than the other or their weights are the same. Indeed, it seems that one may be able to determine whether one set of evidence has greater weight than another only under highly restricted conditions, such as when one set of evidence is a proper subset of the other. And even then, one would not be able to say by how much the weight of one set of evidence exceeds the weight of the other. But regardless of the difficulties encountered when it comes to measuring the weight of evidence or even comparing the weight of distinct sets of evidence, many Bayesians seem to agree with Keynes. The weight of evidence is not a meaningless concept, and however we choose to understand it, it is not represented in an agent's credences. In light of this recognition, the Bayesian has gone to considerable length in trying to show that the Bayesian can account for the weight of evidence in other ways. A very popular response by the Bayesian has been to argue that although the weight of evidence is not reflected in one's credence in H, it is nonetheless reflected in the resilience of one's credence in H. To understand this response, it would be helpful to have a quick look at an example that is often used to motivate this idea, and it's an example that Karl Popper referred to as the paradox of ideal evidence, even though it's not a paradox in any sense of the term. It goes as something like the following. John is presented with a coin and he's asked to assign a probability to the proposition H that it will come up heads next time it is tossed. He doesn't know whether the coin is fair or whether it is biased towards heads or tails. So in light of this ignorance, he assigns a probability of a half to H. He's then allowed to toss the coin 1,000 times and he gets about 50% heads and 50% tails. Call this evidence E. The probability that John assigns to the proposition H that the coin will land heads next time it is tossed is still a half. Popper was troubled by this example. After observing the coin being tossed 1,000 times, John has a lot more evidence concerning the proposition H that the coin will come up heads next time it is tossed, and yet this is not reflected in John's posterior credence in H. The standard reply from the Bayesian to Popper's concerns is the following. True, the weight of evidence is not reflected in John's credence in H, but it is nonetheless reflected in the resilience of his credence in H. This reply goes all the way back to Richard Jeffrey, who noted that although John prior to observing the evidence and John after observing the evidence assigned the same probability to the proposition H, that the coin will come up heads next time it's tossed, they nonetheless assign different values to any proposition AN that asserts concerning N greater than or equal to 2 distinct tosses, that all of them yield heads. To any such proposition, John, after having observed E, assigns the value of a half to the power of N, but to the same proposition, John, prior to having observed E, must assign a higher value if you hope to learn from experience. What Jeffrey is essentially pointing out here is that after observing evidence E, John's credence in H is not going to change very much in the face of new evidence, regardless of what that evidence is. And that is why he assigns the approximate value of a half to the power of N to any proposition AN. On the other hand, prior to seeing the evidence, John's credence in H will increase each time he sees a coin toss yielding heads, and hence why he will assign a probability greater than a half to the power of N to any proposition AN. In other words, as Brian Skims put it, the real evidence has changed not the probability of heads on toss A, but rather the resiliency of the probability of heads on toss A. The reason why after observing E, John's credence in H becomes more easier is not obscure. The difference between the ignorant situation and the ideal evidence situation is that in the former, John assigns a uniform probability density function to the chance of the coin landing heads, whereas in the latter, John's probability density function is concentrated sharply at the hypothesis that the chance of H is a half. Despite this difference, however, John's credence in H is a half in both cases, since John's expectation of the chance of the coin landing head is a half in both cases. Now, whatever one thinks of the Bayesian response to Popper's concerns in this case, it should be recognized that the only cases in which it is plausible to assume that the weight of evidence should manifest itself in the resiliency of one's credence in a hypothesis are cases in which one's credence in that hypothesis is mediated by credences in objective chances. Indeed, notice that in this example, John's credence in H will, in the long term, stabilize around the limiting relative frequency of heads, that is, the actual chance of H. But in cases where there are no chances involved, that is, when dealing with a hypothesis that has no objective chance of being true, the agent's credence in that hypothesis can't stabilize around the hypothesis objective chance. The hypothesis is either true or false, and the best one can hope for is that as the weight of evidence increases, the agent's credence in that hypothesis will tend to get closer and closer to 1 or to 0, depending on whether the hypothesis is true or false. But even that is clearly just a hope, since the weight of evidence increases independently of the extent of the relevance of each incremental piece of evidence, that is, independently of whether the additional evidence is or is not in favor of H. And I'm certainly not alone in thinking it is implausible to assume that the weight of evidence should always manifest itself in the resiliency of one's credence in a hypothesis. For instance, Hammer argues that this situation provides no analogy for a growing body of heterogeneous evidence in juridical proof. Suppose in a wrongful death case, the court was seeking to determine whether, without the defendant's negligence, the deceased would have continued working until 65 years. In this case, there appears to be no basis to expect the evidence or the probability assessment it generates to conform to a regular pattern. The deceased smoked a packet of cigarettes a day, suggesting low life expectancy, but he exercised regularly, suggesting a high life expectancy. But he worked as an industrial chemist with the risk of exposure to highly toxic substances. But his parents are still living and in good health conditions. And his grandparents all lived to 90 years old, but he raised motorbikes, but his diet was extremely good, and so on. In this longevity hypothetical, there is no apparent reason to expect the probability assessment to converge towards a particular point on the unit interval as the weight of evidence increases. Indeed, another way to understand what is going on in the coin flipping example is to notice that the likelihood function for the probability P of the coin landing heads is bound to get narrower and narrower as the number of coin tosses increases. For instance, here you can see how the likelihood function changes from a case in which we observe 6 heads in 10 flips to a case in which we toss 100 times and obtain 60 heads to a case in which we toss 500 times and obtain 300 heads. The likelihood function gets narrower as the number of coin tosses increases. So essentially, the reason why John's credence in H is bound to become more and more resilient as the weight of evidence increases is that in the context of estimating the probability of a Bernoulli trial, the increasing Keynesian weight is achieved by increasing the size of a sample of similar test runs. And because of this, the likelihood function for the probability P of the coin landing heads is bound to get narrower and narrower as the sample size increases. But there is no analogous story to be told in the situation described by Hammer, where one has a growing body of heterogeneous evidence, which starts with relatively raw data for a large reference class and then refines that class by adding individuating factors. As more evidence is taken into consideration, the reference class gets smaller, not larger, because potential comparison cases will be removed. In other words, in cases where we have a growing body of heterogeneous evidence, there is in general no reason to suppose that the weight of evidence is reflecting the likelihood function of a hypothesis. But then, if the Bayesian thinks, as they seem to think, that there is something to the notion of the weight of evidence, and yet the weight of evidence is not always reflected in the likelihood function of a hypothesis, then I argue that this should be enough of a reason in the Bayesian's own eyes to reject the likelihood principle. Now, as mentioned earlier, the notion of severity has very little to do with the notion of the weight of evidence. Why do I claim this? This is because the weight of evidence will increase as more data comes in, independently of whether someone deliberately stops an investigation based on what the data looks like. That is, the weight will increase as the data increases, regardless of how the data was acquired. But to the severe tester, what matters in the assessment of whether one has evidence in support of a hypothesis is not how much relevant evidence one has gathered per se. Rather, it is whether or not the process of generating that evidence has been able to severely test the hypothesis in question. This is partly why I don't believe the weight of evidence is in fact an epistemically well-conceived notion to begin with. And indeed, all I'm arguing here is that the fact that the Bayesian thinks that there is something to the notion of the weight of evidence, and yet is not able to satisfactorily account for this notion, should provide enough of a reason for a Bayesian to reject the likelihood principle. In other words, what I'm arguing is that the Bayesian's recognition that the perceived probability that one assigns to a hypothesis conditional on the available evidence is unable to reflect something that the Bayesian itself seems important about the nature of that evidence, that is its weight, is merely a symptom of the Bayesian's own dissatisfaction with the likelihood principle. I will now try to convince you in the short time remaining that Keynes' notion of the weight of evidence is causing a great deal of trouble and confusion to this day. And I will argue that the confusion partly stems from a failure to recognize that the felt need to account for the weight of evidence is not due to the fact that the weight of evidence is in fact a well-conceived notion that one should account for in the evaluation of the evidential support for a hypothesis, but rather it is simply due to a dissatisfaction with the likelihood principle. According to the Bayesian, there is more to say about the evidence for a hypothesis than its likelihood function, given that evidence, and yet the Bayesian can't account for what that something is. The literature on the legal analysis of evidence, and in particular on the concept of the burden of proof, is a good case in point. Although Bayesian statistics has actually been put to use to evaluate the strength of legal evidence for jury deliberation in several actual court cases, and the Bayesian approach in trial cases has also received the support of a vast range of leading European forensic scientists and professional bodies in recent years. There also seems to be a general discomfort in the literature with the idea that all that is required for a guilty verdict is that the available evidence makes it highly probable that the accused is guilty, because, as Hammer puts it, The probabilistic measure may say something about the evidence to hand, but it says nothing about the completeness or weight of that evidence. A slight body of evidence may give rise to a reasonable degree of probabilistic certainty. But what of the fragility of that assessment, given the many items of further evidence that have not yet been considered? However, some attempts to account for the missing ingredients are admittedly more confused than others. For instance, here's a quote from Davidson and Margherita, who I think were the first to propose that a further requirement for guilt beyond reasonable doubt is that the probability of guilty should have high weight. However, they seem to think that the weight could be straightforwardly identified with the resilience of a probability, which, as I've briefly argued in this talk, is not a warranted assumption. But more recently, in his book, The Burdens of Proof, Discriminatory Power, Weight of Evidence, and Tenacity of Belief, Dale Nance, professor in law and criminal justice and an internationally recognized evidence scholar, argues extensively that adjudication requires the satisfaction of the requisite degree of discriminatory power, which is defined as the ratio between the probability that a given hypothesis H is true, given E, and the probability that H is false, given E. But crucially, he argues that it also requires the practical optimization of Keynesian weight, where practical optimization demands only the acquisition of the evidence that can reasonably be obtained, rather than the realistic acquisition of all the available evidence, whatever the costs. Now, in contrast to Davidson and Margherita, Dale argues correctly, in my view, that it is a mistake to identify the idea of Keynesian weight with the idea of resilience. The two ideas are distinct, and though there are causal connections between them, the dependence relationships are complex. We should not, therefore, embrace the suggestion by Davidson and Margherita that Keynesian weight be identified with resilience of probability. But he goes on to argue that despite all this, the concept of resilience does have some use. The harder it is to shift the probability of interest, that is, the more resilient that probability is, the less is the expected gain in utility of determining which various possible states of an evidence fact obtains before acting. And so the more rational it is to act on the probability one has at the time. Resilience, therefore, is an ingredient in the rationality of acting on a probability by being an ingredient in deciding whether one should augment Keynesian weight by getting more information before acting on one's assessed probability. This connection places resilience in its proper place. In the legal context, it is a component part of the decision by the court whether the case is ripe for submission of the dispute, but for decision by the fact finder. Other factors include the cost of the acquisition of further information, the cost of the additional evidence, and the extent to which the probability falls below or exceeds some threshold of decision. Now, there is clearly a lot to say about Dale's recent attempt to provide a coherent way to account for the weight of evidence in adjudication, but just a couple of key observations that I want to make in light of this, and also all other attempts to account for the weight of evidence in some way or another. As I've argued in this talk, the wish to account for Keynes' notion of the weight of evidence is, in my view, a mere manifestation of a lack of confidence in the Lackroot principle more than anything else. Indeed, I think Dale's attempt to account for the weight of evidence, together with other attempts, are bound to be unsatisfactory from an epistemic point of view. In Dale's case, his requirement of practical optimization of Keynesian weight is clearly epistemically unsatisfactory, because he suggests that whether or not one is justified in declaring to have sufficient evidence for a claim depends on pragmatic factors that have nothing to do with the nature of that evidence at one's disposal, nor how severely that claim has been put to test. The notion of the weight of evidence has also caused considerable trouble and confusion outside the literature concerning legal analysis of evidence. Another good case in point is the Intergovernmental Panel on Climate Change.
You have 5 minutes.
Yeah. The IPCC, which is an international body which synthesizes and communicates the current state of knowledge about climate change so as to provide a scientific basis for governments at all levels to develop climate-related policies. The IPCC authors make extensive use of calibrated language to communicate uncertainty in their findings. Here are some typical findings from the summary for policymakers, where both the Lackroot term and a confidence term are used to communicate uncertainty in a finding. And indeed, the IPCC uncertainty guide provides both a likelihood scale and a confidence scale, and it advises the IPCC authors to use both of these scales to communicate uncertainty in their findings. Likelihood is a quantitative scale and confidence is a qualitative scale. Now, unfortunately, I don't have time to discuss the IPCC uncertainty framework in any detail, but one thing is for sure, and I'm afraid that in this talk you're going to have to take my word for it. Everyone, including the IPCC authors themselves, is very confused about the distinction and relationship between these two distinct scales. And indeed, Johnson, after interviewing several IPCC authors, has recently concluded that most authors agreed that the confidence likelihood distinction was confusing. But one thing that is interesting about discussions of how to best understand the relationship between these two distinct scales is that Keynes' notion of the weight of evidence pops up again and again in pretty much all attempts that have been made to explain what is going on here, and also in suggestions for how to revise and improve the IPCC uncertainty framework. Unfortunately, however, all these attempts are, in my view, rather confused and ill-conceived. Just to give an instance, in his recent and very well-received book, Philosophy and Climate Science, Eric Wisberg argues that we should interpret the IPCC likelihood assignments as imprecise, subjective probabilities in a hypothesis. In this particular case, it is the hypothesis that the equilibrium climate sensitivity lies in the range 1.5 to 0.45 degrees Celsius. And he further argues that one possible way to understand measures of confidence might be as a second order probability. That is to say, the high confidence in the imprecise credence above is a bit like a high degree of belief that the credence will be resilient in the face of future evidence, assessed by looking at the variety of evidence supporting the credence and the degree of agreement among the sources supporting the credence. Now, this is yet another attempt to identify something resembling Keynes' weight of evidence with the resiliency of a probability assigned to a hypothesis in light of the available evidence. And as I've argued in this talk, this is not a warranted assumption.
2 minutes.
And Wisberg's is just one of the several attempts that have been made to interpret or even improve the IPCC uncertainty framework that relies on the intuition that in addition to the assessed probability of a hypothesis in light of the available data, an adequate uncertainty framework should also account for something like what Keynes had in mind with his notion of the weight of evidence. And yet, as I've tried to convince you in this talk, the Bayesian's recognition that the posterior probability that one assigns to a hypothesis given the available evidence is unable to reflect something that to the Bayesian itself is important about that, the nature of that evidence, that is its weight, is not due to the fact that the weight of evidence is an epistemically well-conceived notion that one should account for in the evaluation of the evidence, but rather it is merely a symptom of the Bayesian's own dissatisfaction with the likelihood principle. So, in other words, Keynes' notion of the weight of evidence is, in my view, one of the many casualties in debates concerning the evaluation of evidential support for a hypothesis. And yet lots of people, including scientists, evidence scholars, and philosophers, have mistakenly thought that the weight of evidence is an epistemically important notion that we should account for in one way or another in our relation of the evidential support for a hypothesis. But if I'm right, then people are struggling for the wrong reasons, and I guess someone should try to help them. Okay, thank you.